As the 21st century draws near, economics and technology have compelled us to reach further and probe deeper for the fuels that power our lives. This is the chronicle of one significant episode in the ongoing story of offshore production. An extraordinary combination of advanced technology and proven technique that mobilized the resources of a consortium of leading energy and engineering companies. Gross reserves at Biosca Knoll Block 826 are estimated at 50 to 75 million equivalent barrels of oil. However, because of its deep water location, Block 826 couldn't be developed in an economic fashion with traditional platform technology. Oryx Energy, one of the largest independent oil and gas companies in the world, and its partner, CNG Producing, held development rights to Biosca Knoll Block 826. Exploiting those rights, however, proved to be a challenge.
We had about 50 to 75 million barrels of oil captured, we thought. The concerns were is we didn't quite have enough under the existing development scenarios that currently existed at that time to make this an economic project. We were just slightly under that. So we were searching for ways to make this an economic project, looking at different development scenarios and different facility uses.
We'd like to talk to you this morning about what will result in the installation of the world's first production spar.
Oryx engineers investigated the concept of a floating production spar, a hollow, cylindrical structure similar to a buoy. It would be a simple, versatile structure that, compared with other deepwater alternatives, would significantly reduce the cost of developing Block 826. While spars have been used for decades as marker buoys and for gathering oceanographic data, the Neptunespar is the first to be utilized to support a production platform. After considering all the variables of economics and engineering, Oryx decided to push the potential of spar technology to new limits. The Neptune team was told to proceed.
Well, just as the spar design was the correct technological solution for the project, an effective management team was crucial for cost-efficient project execution. We utilized a very small internal management team, integrated fully with the management of the contractors involved in the project to successfully achieve the project goals.
Oryx assembled a worldwide team of experienced offshore designers, engineers, and fabricators to execute the unique solution that would become Neptune. Working closely with Deep Oil Technology, holder of a design patent on the spar, the original hull specifications were further refined. Aker Offshore, located in Pori, Finland, was chosen to fabricate and assemble the massive spar hull. J. Ray McDermott, headquartered in Houston, Texas, was selected as topside designer, fabricator, and installation contractor. Consolidated Natural Gas Company, one of the nation's largest producers, transporters, and distributors of natural gas, is a 50% partner in Neptune.
For two companies the size of Oryx and CNG to come together and decide to design, fabricate, and install the world's first production spar is quite a remarkable feat. There's been a big learning curve on the Neptune project, but with the team approach, with our management and our subcontractors, it's really worked well. Another key element to the team approach is the use of the internet. Each and every company that's been working on this project has been required to get an internet address. This allows for easy communication between Oryx, CNG, and even Finland, where the hull was fabricated.
The companies that joined forces to design and build Neptune were all leaders in their respective disciplines. Now they combine their resources with virtually seamless coordination, working together in person and by email over the internet to bring the fabrication phase of the project to completion on time and on the money. One of the important cost advantages of the project was that even though Neptune represented an innovative application of spar technology, both Akerama and McDermott were able to use standard construction techniques throughout the fabrication phase. Coordinating efforts across distances of thousands of miles, the Neptune team remained on schedule. And on June 19, 1996, the two hull sub-assemblies were loaded out. The mighty Servant 3, a heavy lift transport vessel, carried them across the Atlantic and the Gulf of Mexico, a journey of 21 days to Ingalls Shipbuilding in Pascagoula, Mississippi. Being offloaded, the two massive main sections of the Neptunespar were joined together. The spar hull assembly, a major project in its own right, took place over a period of 9 weeks. The pace quickened as the work of assembling the hull was brought to its conclusion, and final preparations were made for the official christening ceremony on September 12, 1996.
There was no way we could do this without some individual creativity that brought in new technology that allowed us to not only reduce the cost, but give us a system that would perform on this kind of an operation that potentially we will move and use again and add more reserves and more production for both companies.
In the name of Oryx Energy Company, I christen the FPS Neptune. May you bring success and prosperity to your owners and the other project participants.
In the name of CNG Producing, I christen the FPS Neptune. May the application of this new technology inspire future innovation.
At dawn on September 19, 1996, the Neptunespar embarked on its journey to Viosca Knoll Block 826. Upon its arrival, Neptune team members prepared for one of the most challenging aspects of the entire project, the critical upending sequence.
We have the supply vessel positioned at the base of the spar hull, which is pumping in 300,000 gallons of water into the soft tank area located at the bottom of the spar hull. Once the 300,000 gallons of water have been pumped into the soft tank hatches, the spar hull will begin to rotate a 3/4 of a revolution turn. There it goes. 337. There you go, Ed.
upending proceeded flawlessly, and the 12,000-ton, 705-foot spar settled afloat in the deep blue waters of the Gulf. Neptune had come home.
Good job.
It's just like the modern son of Archimedes lives again.
Yeah, congratulations. Wasn't that special? Man,
Well, we're just like the modern.
The idea that it was the world's first production spar, to install it in 2,000 foot of water, the planning that was required for a first of a kind, where we had to start from a clean sheet of paper and put all the requirements down and then work from there. J. Ray McDermott has installed platforms all over the world for years, and we bring a lot of experience to the table.
In addition to its experience, McDermott brought Derrick Barge 50 to the task of setting the 3,600-ton deck structure atop the floating spar. DB-50 was also instrumental, along with McDermott Lay Barge 280, in the laying of 17.3 miles of oil and gas pipelines for Neptune. The 500-foot-long vessel's powerful main crane had more than enough lift capacity, and its operators had the requisite skill to place the deck onto the hull with delicate precision. Engineering calculations behind Neptune proved accurate on-site and under real conditions. With its deck installed, Neptune's mean water line, 650 feet, matched the original projection exactly.
The spar itself is relatively stable, with little movement as compared to a conventional platform. However, the operational aspect has now become twofold. Because this is a floating production facility, our operations personnel have now been given the responsibility of maintaining the balance and trim of the structure. With the assistance of a computer-generated advisory program, they will operate the balance and the mooring systems.
For Oryx, Neptune confirmed the vision that made the project a possibility and the commitment that made it a reality.
When we looked at the spar, what we found was very encouraging initially. As we looked further, it became compelling economically. What the results now are is that the spar has become the technological answer to a commercial problem. The spar represents the final piece in the marriage of exploration, development, and production technologies. It's the piece that makes us money.
Today, floating in nearly 2,000 feet of ocean water, 90 miles from shore, the Neptunespar represents the leading edge of deep-water production technology. Its innovative design and engineering features and its inherent cost efficiencies have made development of Vioscanol Block 826 economically viable, and Neptune sets the stage for further progress. The spar concept offers the potential to produce at depths as great as 10,000 feet. The only question is when and where the challenges posed by those depths will be met and mastered. The answer will build on the vision and accomplishment of the Neptune participants.